Hello everyone. Today we are laying the groundwork for econometrics by exploring data fundamentals. This presentation will cover essential concepts like data structures and measurement scales, which are crucial for any econometric analysis. By the end of this session, you should be able to recognize different data structures, understand the four primary measurement scales, and confidently classify variables in applied research. Let's start with the basics. What exactly is data in the context of economics? Data represents real-world phenomena translated into a quantifiable form. Think of it as the raw material we use to test our economic theories and make informed decisions. For example, when we study unemployment, we use data on employment rates, GDP, and other relevant factors. This data can come from various sources, including surveys of individuals or firms, carefully designed experiments, or even direct observation of economic activity. Economists work with different types of data, each with its own characteristics and uses. We will focus on three main types: cross-sectional data, time series data, and panel data. Cross-sectional data gives us a snapshot at a single point in time. Imagine conducting a survey of consumer spending in December 2024. That's cross-sectional data. Time series data tracks a single unit over a period. For instance, if we analyze the inflation rate in a country from 2000 to 2020, we are using time series data. Panel data is a combination of both types. If we observe the incomes of 100 individuals every year from 2015 to 2020, we have panel data. This type of data is particularly powerful as it allows us to control for both individual differences and changes over time. This slide provides a visual comparison to solidify your understanding. Take a moment to study the diagrams and think about how each data type captures different dimensions of information. The type of data we are working with isn't just a label. It fundamentally affects our analysis. It determines the appropriate modeling strategy and the statistical techniques we can use. It also influences the assumptions we need to make for valid statistical testing. Finally, and most importantly, the selection of data impacts how we interpret our results. Misinterpretation of data due to a failure to recognize its type can lead to a flawed conclusion or poor decision making. Now let's shift our focus to measurement scales. These scales define how we quantify or categorize variables. Understanding them is essential because they dictate the types of statistical analyses we can perform and how we can interpret the data. We will cover four main types: nominal scales, ordinal scales, interval scales, and ratio scales. It is important to recognize these scales from a high It is important to recognize that these scales form a hierarchy, with each scale possessing the properties of the scales below it plus additional properties. In that sense, ratio scales are at the top, covering interval. Interval scales are below ratio, covering ordinal and nominal scales. Ordinal scales also cover nominal scales without the properties of interval scales. Now let's start with categorical scales, which deal with categories rather than numerical values. Nominal scales are the simplest. They categorize data without any inherent order. Examples of a nominal value would be regions, for instance, like South, North, East, and West. Or gender, male, female, non-binary would be categories under the gender value. Now we can assign numbers to these categories, but those numbers are simply labels or identifiers. They are not necessarily magnitudes. Ordinal scales introduce order. Categories have a meaningful sequence, but the intervals between them aren't necessarily equal. Education levels measured at high school, bachelor's, master's, and doctorate are a classic example. We know that a master's degree is higher than a bachelor's degree, but we cannot quantify the distance between them. Next, we move to numeric scales, which involve actual numerical values. Interval scales have equal spacing between values, allowing us to measure differences. However, they lack a true zero point. Temperature measured in Celsius is a good example. The difference between 20 degrees Celsius and 30 degrees Celsius is the same as the difference between 30 degrees Celsius and 40 degrees Celsius. But 0 degrees Celsius doesn't mean the absence of temperature. In fact, when you look at a Fahrenheit or a Kelvin measurement scale for temperature, we see that the 0 degrees Celsius is different in those, which means there is no real zero point when it comes to temperature. Ratio scales, on the other hand, are the most informative as they have equal spacing and a true zero point, indicating the absence of the quantity being measured, for instance. So income, age, height, and weight are all ratio scale variables with a true zero point. A zero income means no income, and someone who is 20 years old is twice as old as someone who is 10 years old. To solidify your understanding, let's look at some real-world examples. As an example for nominal values, country origin can be used. There's no inherent order to the list of countries when it comes to country of origin. As an example for an ordinal scale, we can use satisfaction ratings. For instance, on a scale from very dissatisfied to very satisfied, when we measure consumer satisfaction ratings, we can see a clear order, but the difference in satisfaction between each level might not necessarily be equal. As an example for interval values, SAT scores can be used. The difference between a score of 1000 and 1100 is the same as the difference between 1100 and 1200, but a score of 0 does not necessarily mean zero knowledge. A perfect example for a ratio value is household income. $0 means no income, and $100,000 is twice as much as $50,000. To wrap up, remember that both data structure and measurement level are foundational concepts. Misunderstanding them can derail your entire analysis. Our next module will cover sampling and measurement, and once you are familiar with the concepts covered in this current module, feel free to move to the next module. Thank you.